Hey there, let's talk about forces and the related free body diagrams. We'll talk about what a force is and distinguish between contact and non-contact forces. We'll determine what a normal force is, and then we'll draw a free body diagram of an object at rest and another free body diagram of an object in acceleration. In the simplest sense, a force is a push or a pull. A contact force arises when something is touching an object. There's different kinds of contact forces. Our normal force, which we'll talk about in a little bit, tension, like the string acting on this ball, air resistance, which is air touching an object, or friction, two objects rubbing against each other. Non-contact forces are where two objects are acting on each other from a distance. Gravitational force is a non-contact object, and so is electromagnetic force. We won't deal with electromagnetic force in 211, but we will deal quite a bit with gravitational force. That comes about because massive objects attract each other at a distance. A free body diagram is a very useful diagram to use in a force approach. In much the same way as we did in kinematics, we'll use free body diagrams to derive the equations of motion that we can use to do the analysis. For a particle, we'll represent the object as a dot. We'll draw force vectors acting on the object, keeping in mind that they have magnitude and angle. Here we have a tension force acting from the thread and gravitational force, non-contact force, acting downward toward the center of Earth. We label the force vectors, tension, and the force due to gravity. The next thing to do is include a coordinate system. And if there's an angle involved or multiple angles, we want to identify those angles with respect to the coordinate system. A normal force is a specific kind of a force that is a contact force. It's perpendicular to a surface. Here we have an object resting on a table. The force due to gravity is acting downward on the object. The normal force is acting upward on the object from the table. If we have an object that is on a slanted surface, the normal force is still perpendicular to the surface. We may want to rotate the coordinate axes to keep the acceleration along one of the coordinate axes. A normal force arises to be what it needs to be to keep the object from going through the surface. For example, a small dog and a large dog are both sitting on the floor. The normal force acting on the large dog is bigger than the normal force acting on the small dog. That's because the mass of the large dog is bigger than the mass of the little dog. The microphysics here is that there are electrons in the material in the surface of the floor, and there are also electrons in the feet of the dogs. Those electrons are repelling each other. The normal force arises from these electromagnetic repulsions, but we think of it as just a macroscopic normal force. Normal here meaning perpendicular to a surface. In summary, we can identify forces acting on an object as contact and non-contact forces. Force is basically just a push or a pull. We use free body diagrams to represent forces on an object, starting with representing the object as a dot at the origin. We include any force vectors on the object, drawing them out of the origin, keeping in mind that they have magnitude and direction. We then include a coordinate system that we may want to rotate based on our system, and draw any angles that are in the system represented on our free body diagram. Normal force is a particular kind of a force that is always perpendicular to a surface and arises in magnitude with respect in response to the surface. Thank you for coming. Come again soon.